The Milky Way and Andromeda Galaxy have been moving towards each other for a long time, and scientists thought they wouldn't collide for billions of years. But surprise, turns out they were wrong. The James Webb Telescope just sent a surprising message. The collision has already started. Scientists are worried and trying to understand what's going on and how it will affect Earth and our galaxy. Watch till the end to know the secret about why the James Webb Telescope is sending an alarming signal from the Andromeda Galaxy. In 1750, the English astronomer Thomas Wright suggested that the Milky Way is not only a swarm of stars scattered randomly but a very big flat layer of them. Although Wright's idea was shackled by the tools available to him, he opened the way for the scientists to come. The era of the early 1900s saw the development of improved telescopes, which was a turning point in the astronomy world. He discovered that the nebulas at a great distance, which were formerly thought to be part of the Milky Way, were in fact separate galaxies. Andromeda, or M31, was one of the galaxies he looked at. Andromeda is not just any galaxy. It's the closest galaxy to us and has been observed for ages. In the 10th century, Persian astronomer al-Sufi described it as a small cloud. Without telescopes, Andromeda is observable from Earth even without any special tools. In 1762, Simon Maris began his detailed observations of Andromeda, and in 1764, Charles Messier added it to his catalog with the M31 catalog number. These milestones stress the point that Andromeda is an important part of the history of astronomy. William Huggins, an English astronomer, made a remarkable discovery in 1864 regarding the Andromeda Galaxy. This finding was the foundation for further exploration of the universe. He discovered Andromeda's spectrum to be dissimilar from ordinary gaseous nebulae. Thus, this discovery marked a turning point in comprehending its real nature. Although Andromeda is near to us, it is a vast cosmic entity, which, according to estimates, is 1 to 2,000 times heavier than our Sun. It is about 10 billion years old, meaning that it must have been built through the merging of smaller protogalaxies. For years, astronomers thought Andromeda was much more massive than our Milky Way. Recent findings, however, do not support this belief, showing that their mass is actually closer than previously thought. This highlights the difficulties in determining the mass of galaxies accurately. The spatial dimensions of the Andromeda Galaxy also entice astronomers. It has a diameter of around 220,000 light-years, which is greater than the Milky Way, thus dominating a large section of space. Although we have a much better understanding of this object, there are still many secrets that we have not unveiled. Interestingly, this object has a supermassive black hole at its core and an active galactic nucleus, a highly energetic region that radiates intense radiation in various wavelengths. Hubble telescopes have been able to find some very interesting things at Andromeda's center. This is where a supermassive black hole is situated, whose mass is 110 to 230 million times our Sun's mass, and it is emitting tremendous radiation. It creates an environment with stars moving differently from the rest, making bright spots. Andromeda is also well known for its globular clusters, which are assemblies of very dense and old stars, showing that it has been involved in several interactions with smaller galaxies, amounting to about 460. Scientists believe that the Andromeda Galaxy is transforming its usual spiral form into a less common ring galaxy. Ring galaxies are unique in that they have a ring-like shape that is either circular or oval. The rings are characterized by young, bright, blue stars, and the brightness of the matter in these galaxies is less in the center. What factors might be contributing to this intriguing transformation in the Andromeda Galaxy? And how might it impact our understanding of galactic evolution? If the Andromeda changes are confirmed, it would make Andromeda an even more interesting galaxy in the universe. Ring galaxies like Andromeda fall into two main types, O-type and P-type. The central part of an O-type galaxy is characterized by a smooth, regular ring shape, while the nucleus of a P-type is not in the center, and the rings are more irregular. Ring galaxies are like rare gems in space, with only 0.01% of all galaxies fitting this specific kind. Astronomers have proposed two primary ways these galaxies could be developed: the collision of two or more galaxies, or when a smaller galaxy is in the center of the larger one, resulting in a ring shape. In terms of galaxy collisions, examples like the Cartwheel Galaxy, Pegasus, and ARP-147 show how galaxies have been transformed into ring galaxies. However, what is taking place with Andromeda is more intriguing. Astronomers envision that our Milky Way and Andromeda galaxies will collide in the future and form one large galaxy. This big event is well known because it gets funny nicknames like Milcam or Milk Drummer. While the merger of these two banks may be marked by playful names, the consequences would be tremendous for us. With the approaching of the two galaxies, their strong gravity will already have started to distort each other's shapes. This will result in so-called tidal interactions, during which stars, gas, and dust are trapped between galaxies, disrupting their behaviors in profound ways. Galaxies that take part in this process will experience alterations in the courses of their stars, thus creating a very dynamic and disordered system in the newly formed galaxy. The supermassive black holes at the centers of both galaxies will, after the merger, form a bigger black hole at the center of the new galaxy. The collision can trigger starbursts, which flash out in bursts of bright stars, shock waves, and clusters. On the other hand, these celestial occurrences will not be restricted to just visual displays. They will also have an environmental tone, with disruptive circumstances such as space radiation, solar radiation, and changes in the galactic interstellar medium. These changes may alter the Earth's atmosphere, causing climate change, weather anomalies, and ecosystem disruption. The merging of the Milky Way and Andromeda may result in the greatest changes that will directly affect life on our planet. These changes are often negative for the habitat and may lead to a shift in biodiversity, with some species facing local extinction. Such cosmic fusions may generate new atmospheric compositions or climate change patterns, which could make some habitats less suitable for many species, breaking their migration routes. These disruptions can be problematic in terms of finding water, food, and a suitable area for laying eggs, which would negatively impact the number and variety of species within ecosystems. On the other hand, some organisms may be resilient and adapt, but vulnerable organisms could be devastated and at risk of local extinction. The disruption of habitat and migration patterns could lead to changes in the system as a whole, possibly resulting in local extinctions. In terms of timing, the collision isn't going to happen immediately. It is expected that it will take another 2 billion years to complete the merger of the Milky Way and Andromeda galaxies, which is predicted to begin 5 billion years from today. By then, the Sun will have become a red giant for billions of years, so humans will not have been able to inhabit the solar system by that time. If our descendants or other life forms survive billions of years into the future, their existence will be vastly different from how we are now. The fate of our solar system in the next supergalaxy is also uncertain. Nevertheless, the solar system could be shoved off into the space between galaxies in case of the collision. The new galaxy's structure will remain a mystery, and we don't know for sure what will happen to our solar system. It might get thrown out into space, but we can't predict exactly what will happen. However, in this merged galaxy, there could be star systems with planets in a good spot for liquid water. Life that starts there might be different from what we know on Earth. Even though humans today wouldn't survive there, it's interesting to think about the possibility for new kinds of life in this different galaxy. What adaptations might life in these environments undergo? And how could it reshape our understanding of the diversity of life in the cosmos? The collision between the Milky Way and Andromeda will not only reshape the structure of the two galaxies, but also offer astronomers an unparalleled opportunity to observe a galactic merger in real time. Such cosmic events are rare in the universe, and studying them can provide crucial insights into the fundamental processes of galaxy formation and evolution. The interaction between galaxies, especially on the scale of a merger, offers clues to how galaxies evolve over billions of years and how they eventually settle into their final forms. One of the most fascinating aspects of this cosmic collision is the phenomenon of star formation. The intense gravitational interactions between the two galaxies will cause vast clouds of gas and dust to collide and compress, triggering bursts of new star formation. These starbursts are often short-lived but incredibly intense, producing hundreds or even thousands of stars in a very short time. Some of these stars may even end up in the galactic center, contributing to the buildup of the new supermassive black hole that will form as a result of the merger. The new stars created during this process will have different characteristics from older stars, and some of them may even help form planets that could potentially harbor life in the far future. However, the formation of new stars is not without consequences. The merger of two galaxies typically leads to the disruption of existing stellar systems. Some stars will be thrown out into intergalactic space as a result of the gravitational interactions, while others will be pulled into the supermassive black hole at the center of the new galaxy. The tidal forces that result from such a collision can also distort the shapes of individual stars and planetary systems, making them unstable. In some cases, the intense radiation and shock waves generated by the merger can sterilize entire regions of space, rendering them inhospitable to life. Beyond the immediate effects on stars and stellar systems, the merger of the Milky Way and Andromeda will have profound implications for the dark matter that pervades both galaxies. Dark matter, which is an invisible form of matter that cannot be directly observed, is believed to make up the majority of the mass in most galaxies. It interacts with regular matter through gravity, but its exact nature remains one of the greatest mysteries in astrophysics. During a galactic collision, the distribution of dark matter is altered, potentially leading to the formation of new dark matter halos or the merging of existing ones. This can impact the overall structure and dynamics of the resulting galaxy and may even help scientists finally unlock some of the secrets of dark matter. As the two galaxies merge, the surrounding intergalactic medium, essentially the gas and dust that exist between galaxies, will also be affected. The collision will cause a tremendous amount of pressure and heat, resulting in the creation of shock waves that will propagate throughout the gas. This will trigger the formation of new clusters of stars and galaxies, which could contribute to the formation of a new galactic supercluster in the distant future. As the gas is compressed and heated, it may also produce intense X-ray and radio emissions, offering astronomers a unique opportunity to study the physics of high-energy processes in space. On an even larger scale, the merging of the Milky Way and Andromeda will have implications for the structure of the entire local group of galaxies. The local group, which is the cluster of galaxies that includes the Milky Way, Andromeda, and dozens of smaller galaxies, will undergo significant changes as a result of this collision. Some smaller galaxies may be absorbed into the newly formed galaxy, while others may be ejected from the local group entirely. This will alter the overall dynamics of the group, potentially leading to a shift in the balance of gravitational forces between the galaxies. Such changes could have far-reaching consequences for the evolution of the local group and its member galaxies. The merger of the Milky Way and Andromeda is a dynamic, multi-stage process that will unfold over billions of years. In the initial stages, the two galaxies will begin to pass through each other, their shapes distorted by the gravitational forces at play. As the collision progresses, the galaxies will continue to interact, exchanging gas, dust, and stars, which will eventually lead to the formation of a new, larger galaxy. This process is known as a galactic remodeling, and it can take hundreds of millions of years to complete. During the final stages of the merger, the two supermassive black holes at the centers of the Milky Way and Andromeda will eventually merge, creating an even larger black hole at the heart of the new galaxy. The immense gravitational forces produced by this merger will cause ripples in spacetime, known as gravitational waves, which will be detectable by future gravitational wave observatories. This event will be one of the most energetic and significant events in the universe, offering scientists a unique opportunity to study the fundamental nature of space, time, and gravity. The Milky Way and Andromeda are not the only galaxies destined to collide. Galaxies are constantly interacting with one another throughout the universe, and collisions between galaxies are a natural part of cosmic evolution. In fact, the local group itself is expected to undergo more mergers in the distant future. Smaller galaxies like the Magellanic Clouds, which orbit the Milky Way, will eventually be absorbed into our galaxy, further altering its structure. Similarly, the Andromeda Galaxy is not alone in its interactions, as it is also part of a larger cosmic web of galaxies that are gravitationally bound together. In addition to these large-scale galactic mergers, there are smaller-scale interactions between galaxies that occur more frequently. For example, dwarf galaxies, which are small and faint, often pass through larger galaxies and can be absorbed into them over time. These interactions can trigger bursts of star formation and can also lead to the development of new structures within the larger galaxy. The study of these smaller-scale interactions is crucial for understanding the processes that drive the growth and evolution of galaxies throughout the universe. As we continue to study these cosmic events, we gain a deeper understanding of the forces that shape the universe and the potential for life beyond Earth. The merging of galaxies like the Milky Way and Andromeda highlights the dynamic and ever-changing nature of the cosmos. Although the immediate effects of such a collision may be catastrophic for life on Earth, the long-term consequences could lead to the formation of new and potentially habitable environments in the resulting galaxy. The collision of the Milky Way and Andromeda may mark the beginning of a new era in the history of the universe, one in which new stars, planets, and possibly even life emerge in the wake of a cosmic transformation.